Hi, folks. All right, so today we're going to talk about this idea that is often referred to in mathematics as completing the square. All right, so just to kind of back up for a second, we have talked about various types of equations in the world of polynomials. Okay, this idea, completing the square, really focuses on a specific kind of polynomial called the quadratic. Okay, now all polynomials come in many different forms, but some are easier to graph than others. Okay, and I understand we have various graphing tools such as Desmos and our calculator at our disposal, but it's also important that we can understand how these graphs would look based on their equation and be able to rewrite them in various forms. So that's what we're going to focus on today. Suppose you were given an equation in one form, perhaps standard form, but you would really prefer to look at it in, let's say, vertex form. Okay, so what that basically means is that we're going to start out with something that looks like ax squared plus bx plus c, and we're going to convert it to y equals a times x minus h squared plus k. The completing the square part comes in because you're going to rewrite the x squared as a quantity squared. Okay, so we're going to take an equation and we're going to start with it in standard form. This guy right here is in standard form. So here's how we're going to convert it. All right, you ready? Let's go. So step number one is that you are going to shift or move the c value to the other side. Okay, so what does that look like? That looks like f of x plus 7 equals 2x squared plus 4x. Okay, and if you're wondering why are we doing this, well, the idea behind completing the square is that you have a perfect square trinomial. And right now, we can't possibly have a perfect square trinomial because 7 isn't a perfect square. Okay, second thing you're going to do is you're going to factor out the a value, okay? Because you need a to be 1 in order to complete the square. So nothing changes on the left-hand side. We still have f of x plus 7. However, on the right-hand side, we now have 2x squared plus 2x. And then I'm going to leave a space here. So I've taken out the a value that I took out is this number right here, 2. And I took it out of both coefficients. All right, okay, so here's the big part where we're actually completing the square. We are going to add, and I use the word add in quotation marks because it may end up at times being subtraction if you have a negative a value. B divided by 2 squared to both sides. This is how we find our new c value. Okay, so here's the deal. Our goal is to make this a perfect square trinomial. And in order to do that, the number that goes here has to be the perfect square we need to make this some quantity squared. What is that number? That number is 2 in this case, because that's our b value, divided by 2 squared. That number is 1. So we are adding 1 right in here in these parentheses. Now here's the kicker. Adding 1 inside the parentheses means you're really adding 2 outside them because it's 2, that's the a value, times your c value that you just picked. So 2 times 1. So here's what we've got. We've got f of x plus 9 equals 2 times x squared plus 2x plus 1. Okay, to recap, by introducing the 1, this quadratic right here is now a perfect square, meaning if I went to factor it, it would be the same binomial repeated, right? X plus 1 times x plus 1 would get you x squared plus 2x plus 1. That's exactly what we want because that means we can rewrite that as x plus 1 squared, right? A quantity squared, with our a value out in front. The only thing we're missing is that k value, which is going to come from moving that 9 over to the other side. So now we have f of x equals 2 times x plus 1 squared minus 9. So the fourth step, after you kind of add that c value, is you rewrite in vertex form. So that includes factoring the quadratic and moving the k value back to the right-hand side. Okay, so now our new equation is 2, here I'm just going to use y, 2 times x plus 1 squared minus 9. That means, oh sorry, I shouldn't really write it here. I'll rewrite it over here. Y equals 2x minus 1 squared, or sorry, x plus 1 squared minus 9. This tells us that our vertex is at -1, -9. Now our original equation, y equals 2x squared plus 4x minus 7. This equation still has some value because it more easily indicates to us that our y-intercept is at 0, -7. Okay, so I'm going to start plotting some of these points. So -1, -9 is right here. 0, -7 is right here. And based on the fact that I know that this graph has an axis of symmetry at -1, I know I can mirror that y-intercept point to the other side. Okay, now to find the x-intercepts, I could take either one of these equations and set them equal to 0. I'm going to set the vertex form equal to 0. Let's see what we get. I'm going to get 9 over 2 equals x plus 1 squared. Square root of both sides. So x plus 1 equals 3 over the square root of 2 plus or minus that value. So it's going to be -1 plus or minus 3 over root 2. I do not know exactly where those numbers are. I could approximate them, but let's see if we can find some other points using the pattern of quadratics. So if the normal pattern away from our vertex is that if I go left 1, I go right 1, and if I go right 1, I go up 1. What about if I went to 2? That'd be 4, -2, that'd be 4 units up. So because my a value equals 2, I would multiply all those heights by 2. So that means if I go 2 units over, I go 1, 2, 3, 4, 5, 6, 7, 8. I'd have a point right here and a point right here. And if that table that I just did doesn't make any sense, let me show you this from this perspective. Normally there'd be a point 2 units over and then 4 units up. So 2, 1, 2, 3, 4. Normally there'd be a point here, but this distance is being multiplied by 2 because of our a value. So that is why there's a point here, 8 units up, because 2 times 4 is 8. And so then I mirror that point to the other side. And then technically the next point is normally 9 units up, which would put me here. So then double that would be 18. So here is a look at our parabola. You didn't necessarily need those last 2 points, but it does make it look a little bit more clear in our graph. Okay, so what I'd like you to do right now is I would like you to practice converting this quadratic into vertex form. So keep in mind, standard is this guy, ax squared plus bx plus c. Vertex form is this right here. And then just a couple of other little helpful tips. The vertex, like the x value, is always at the opposite of b over 2a. So you can also check your work by doing that. Okay, so go ahead and give these two a try, and then you can listen to the walkthrough afterwards. All right, welcome back. So number 2, let's run it through. So I'm going to take this 1, and I'm going to move it to the other side. So f of x equals -1. And then I've got negative x squared minus 4x. Now, it may not look like it, but there is an a value here of -1 that I'm going to factor out. So it's going to be x squared plus 4x plus something. That something is whatever 4 divided by 2 squared is. And that is 4. So I'm going to add 4 into these parentheses. But when I do that, that number is getting multiplied by -1. So I'm really adding -4. So at this point, I have f of x minus 5 equals negative x squared plus 4x plus 4. And then this is the part where we clean up and rewrite in vertex form. So this turns into x plus 2, that quantity squared. And then my final vertex form is minus x plus 2 squared and then plus 5. And just a little heads up, as I mentioned at the top in purple, the vertex is supposed to be at, another way to find it, the opposite of b, so the opposite of -4 all over 2 times a. So the x value should be 4 divided by -2. -2, that's true, because if it's positive inside the parentheses, you do the opposite, so that works out. And then if I substitute in -2 into the original equation, I should get 5. Okay, what about number 3? Looks like we've got some fun happening over here. All right, first thing, still going to take the the 11, move it over, and I've got 2/3 x squared minus 18x. Okay, now I could understand the initial response to this problem being to, let's say, multiply everything by 3. The problem is then you would be changing the a value, and we want to maintain the equation. Okay, we want to keep it in the same location. So we can't do that. So we're going to take the 2/3 out. And so then the question is, what number would I have in front of x? Okay, so that's going to be kind of important. So you basically are dividing, I'm just going to write this over here. You're taking -18 and you're dividing it by 2/3, which means you're taking -18 and you're multiplying it by the reciprocal. Okay, so really what I'm going to have is -27. Okay, because if you think about it, if you distribute the 2/3 back in, it'll make the 27 smaller, meaning back to 18. Okay, so now I'm going to take -27 and I'm divide it by 2 and I'm going to square it. And I know you're like, crap, Mrs. Fry, really? With this -27 halves? Guys, it's fine. It's really fine. And it's so fine that I'm even going to let you just say that it's 27 squared over 4. Okay? And part of the reason why I'm going to do that is because we're going to have to multiply that by 2/3 anyway. Okay? Whew. And we're going to have to add that. So let me do a little math over here for you. So we're going to have 27 squared, which, by the way, 27 is 3 to the 3rd. So this is really 3 to the 6th over 4. That's really what number we're working with here. That number is being multiplied by 2/3. So we're going to divide 4 by 2, and we're going to take one of these guys out. So we've got 3 to the 5th over 2. 3 to the 5th is 273, because it's 81 times 3 over 2. And then we're going to turn 11 into 22 halves. All right, I know, the numbers are kind of gross. Guys, it happens, okay? So then we've got f of x plus 251 over 2 equals 2/3 of x squared minus 27x plus 27 over 4. That number is squared. Sorry, I meant to put that whole thing in parentheses. Oh, I'm sorry. Yeah, just the 27. My apologies. All right. Okay, so our final kind of crazy looking quadratic is 2/3 of x minus. Now, 27 over 4, 27 squared over 4, came from 27 over 2. That's the h value. And then our k value is negative 251 over 2. I know, not super pretty. You're probably like, I wouldn't have really wanted to graph this quadratic, and I can understand that. But that's what our final product would be. Okay, or I should say our final vertex form would be. All right, last thing to just chat about. If you're ever asked to write an equation from a graph, I would save standard form for last. I would start with vertex or factored form, okay? Factored form is nice because you can just look, okay, I know I need an a value, but you can just look at your factors and be like, okay, looks like I've got a factor, an x-intercept at negative 3, so x plus 3 is a factor, and looks like I have an x value at 1, so x minus 1 must be a factor. So I still got to figure out what my a value is. But if you figure it out once, it's the same a value for all 3 equations. And then your vertex form, okay, you can be like, looks like I've got a vertex at negative 1 comma 8. So again, don't know what a is, but I know I have x plus 1 because it's minus negative 1, so that makes it positive, plus 8. It is at this point when it would be helpful to take a look at the shape of your graph. Be like, where's the next point? That next point is down 2 units. And where's the point after that? It is down 8 units. Normally, it would be down 1 and down 4. Those are both double. So my guess is that our a value is negative 2. And no, it's not really a guess. We know that if the parent function is changed, is dilated, that's our a value. Okay, and then we would just multiply. We would take either of these equations and multiply them out to figure out what your standard form is. So I'm going to take factored form, and I'm going to say we've got y equals negative 2 times x squared plus 2x minus 3. So that means we have y equals negative 2x squared minus 4x plus 6. Okay, and notice I got 6 at the end. 6 is my y-intercept. That should at least check out, all right? It's a good way to check and make sure you did your math right. All right, thank you so much. Have a good one. Thank you for listening. Adios.